Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss RC coupled amplifier. Let's begin. First of all, we understand what is amplifier. An amplifier is an electronic device that amplifies the magnitude of the applied input signal. That applied input signal may be voltage, current, power or any kind of electronic signal. That signal is amplified by using an amplifier. There are various kinds of amplifiers. If we consider a single stage transistor amplifier, then it consists of one transistor. If we consider a multi-stage transistor amplifier, then a number of transistors are required, and in that particular multi-stage transistor amplifier, as a number of transistors are used, so these transistors are coupled with each other. In a multi-stage amplifier, the output of one stage is coupled to the input of next stage by a coupling device. That coupling device may be resistor, capacitor, inductor, whatever may be that coupling device. The output of one is coupled to the input of another. For that reason, we call it as coupled amplifiers. Here we discuss about RC coupled amplifier. The amplifier is called resistance capacitance coupled amplifier because the coupling from first stage to that of second stage is achieved by a coupling capacitor. For that reason, we call it as RC coupled amplifier. That coupling capacitor followed by a connection to a shunt resistor. What is its construction? It is a two-stage transistor amplifier. So, two transistors are required. One transistor, two identical transistors, NPN transistor with common emitter configuration, again another NPN transistor with common emitter configuration, transistor 1, transistor 2. In that of transistor, throughout that of base, we connect the resistances R1 and R2. That type of arrangement is called the voltage divider arrangement. Why that type of arrangement we prefer? To stay that transistor to be proper biased, we use voltage divider biasing. Again, R1, R2. That of emitter, a resistor having resistance Re, emitter resistance, the capacitor, that Re is used to fix the Q point, means it provide proper stabilization to that of transistor. To fix that Q point we use Re. Similarly, for transistor T2, capacitor Ce. The working of that capacitor Ce, when an AC signal is inputted to that of circuit, it is not purely AC, it is the combination of AC plus DC. As we know, capacitive reactance, capacitive reactance that is Xc is equal to 1 by 2 pi nu c. Nu is the frequency, c the capacitance. For DC, nu is equal to 0, therefore Xc tends to infinity. That expression indicate that capacitor is act as a filter. It passes AC throughout this and opposes to that of DC signal. For that reason we use CE. Here a resistor, RL, throughout this the output is through that of collector is measured across that of RL. Now, this is one stage transistor amplifier, that one is another stage transistor amplifier. These two are coupled by using a capacitor which is called coupled capacitor, coupling capacitor. So, the output of first stage coupled capacitor C, the input of another stage. We provide AC signal to the first transistor T1, again use another capacitor input AC signal and input signal, why that capacitor is used, again for that reason it allowed AC through it and opposes DC. that end connected VCC, point potential. The output capacitor, coupling capacitor C, and the output is measured across this V output. Is asked. That one is the circuit diagram of a two-stage RC coupled amplifier. Two-stage RC coupled amplifier. One transistor, another transistor. This is the output of first transistor, input of another transistor. These two are coupled by a coupling device, capacitor. As we provide input signal, let we analyze it. If we apply input signal, input AC signal, positive half cycle, negative half cycle, throughout that of capacitor, it allows AC and obstruct the DC. Now that signal to the base of the transistor T1, whereas R1 and R2 are used to provide proper biasing to that of transistor T1, and RE also used to stabilize, means to fix that of Q point. Next, CE allows AC through it and obstruct DC. Again it is used to calculate that voltage drop across that of RE, to minimize the voltage drop across RE. At output in that of collector through that of load, we obtain the output signal which is the amplified version but out of phase. That phase shift is 180 degree. Here positive half, but there we obtain negative and positive, amplified but out of phase. Throughout that of C capacitor, it allows AC obstruct the DC. Now that input signal to that of transistor T2, again R1 and R2 provide proper biasing, and CE again to stabilize the transistor T2 and the output across that of RL. And finally we obtain the output signal throughout that of RL, which is the amplified version, but shifting the phase, amplified and shifting the phase. Now this is the input signal, output signal as amplified with same phase. So by using RC coupled amplifier, we obtain the amplified signal. What we describe it in that of construction section, just elaborate in that of working. The resistances R1, R2 and Re form the biasing and stabilizing network and establish the operating point, as we say R1, R2, Re. Here R1, R2, Re for that of transistor T2. The bypass capacitor Ce across Re offers low reactance path to that of AC signal, and hence only DC components of emitter current produce a voltage drop across Re. Without Ce, the voltage gain of each stage would be lost. Across Re, we use Ce as mathematically we show that capacitor opposes to that of DC and allow AC through it. For that reason, we use Ce across that of Re in case of transistor 1 and transistor 2. Next, when AC signal from an AC source is applied to that of base emitter circuit of first transistor T1, AC signal to that of base emitter circuit to first transistor T1, it appears in the amplified form across the load RL in the collector circuit. Now that signal is amplified but out of phase, that phase shift is 180 degree across that of RL. The amplified signal developed across RL is applied to that of base of second transistor T2 through that of coupling capacitor C. Now that amplified signal to that of base of transistor T2 by the coupling capacitor C. The second transistor T2 does further amplification of the signal, and amplified signal appears across the collector load RL of that of T2. Again, the amplified signal we obtain across that of collector load RL, that is the amplified signal. In this way, the cascaded stages amplify the signal and the overall gain of that of RC coupled amplifier is considerably increased. That is a cascaded stages. Cascaded stages means the output of one is the input of another by using a coupled device. That type of arrangement is known as cascaded arrangement. So, in each stage, each cascaded stage, we obtain the increased amplification. That signal is amplified. In that of further state, also amplification holds good. That is the working of that of RC coupled amplifier. Next, we analyze how that RC coupled amplifier responds to frequencies. Frequency response. If we plot a graph in between frequency and voltage gain, here is the frequency, in x axis voltage gain, for that of frequency range around 50 Hz to 20 kilohertz. The graph just looking like this. That is the maximum voltage gain, A V max. Three ranges of frequency obtained: 0 to 50 Hz, that is the low frequency range, that frequency range, the low frequency range, from 50 Hz to 20 Hz, the mid frequency range, mid frequency range, and above that 20 Hz is the high frequency range. In low frequency range below that of 50 Hz, the voltage gain also low, and at a high frequency range above that of 20 kilohertz, again the voltage gain low, but in that of region 50 Hz to 20 Hz, that is the mid frequency range, we obtain the maximum voltage gain, a stable voltage gain we obtain, and that voltage gain to that of a frequency we can easily analyze by using that of expression capacitive reactance 1 by 2 pi nu c. If frequency is low, means capacitive reactance is too high, capacitive reactance too high, indicating that a huge opposition towards that of DC, and ultimately the voltage gain low. In this way, how voltage gain is responding to that of frequency we show. Next, what are the advantages and the disadvantages of that kind of amplifier? Advantages: it has excellent frequency response. The voltage gain is uniform over the audio frequency range. That mid frequency range around 50 Hz to 20 Hz, which is called the audio frequency range. Inside that of audio frequency range, the voltage gain is uniform. So, it is a good response to that of frequency. Next advantage, it is not expensive. Why? Because it employs resistors and capacitors, which are cheap. In less amount expenditure we can buy resistor and capacitor. So, for that reason that RC coupled amplifier is also cheap to us. Next advantage, it is small and light. Why? We use resistor and capacitors. In modern day, the resistors and capacitors also small and light. Therefore, the RC coupled amplifier also small and light. Next, disadvantages. It has low voltage gain and power gain because the input of one stage provides the low resistance to the next stage and decrease the effective load resistance, and hence decreases the voltage gain and power gain. As we say, the input of one stage provides low resistance to that of next stage. As a result, voltage gain and power gain are highly influenced. Low voltage gain and power gain we achieved. That one is the disadvantage of RC coupled amplifier. Next disadvantage, it becomes noisy with age and moist climates. In moist climatic condition, as well as if it is in older times to use, or in a long run it is noisy. Applications of RC coupled amplifier. These amplifiers have excellent audio fidelity over a wide range of frequencies as we discussed. Hence, they are widely used as audio frequency amplifiers. So, these are some basic advantages, disadvantages as well as applications of RC coupled amplifier. So, here with the help of this video lecture we understand the concept of RC coupled amplifier, construction of RC coupled amplifier, working of that kind of amplifier, frequency response by taking that particular graph, advantages, disadvantages and applications of RC coupled amplifiers. So, with this useful and informative notes, let me wind up this session. Thank you.